In this example, I'd like to show you the similarities between these two equations. One is set equal to 0, the other one is set equal to y. In this process, I want to expose a pattern that will be useful when trying to convert into vertex form. To make things more clear, I'll rewrite the equation on the left so that 0 is facing to the left of the equation. I'll proceed to complete the square, and recall that to complete the square, you use the first two terms, x squared and the x term. To complete the square, I'm going to use this recipe, getting the b term, dividing it by 2, and then squaring it. Keep in mind that the b term is the coefficient of x. In this example, that's going to be the negative 6. So here, I'm going to grab negative 6, divide it by 2, and then I will square that. I will simplify what's inside of the parentheses first. So negative 6 divided by 2, that's negative 3. And if we raise that to the second power, we should get a positive 9. In order to complete the square using these two terms, we need to add a value of 9. Now, if I add a 9 to the right side of the equation, naturally I would have to add 9 to the left-hand side of the equation. Since I have equality, I have to remain the balance. Whatever I do to this side, I would do to the other side. So simplifying here, 0 plus 9 would give me 9. And on the right-hand side, I'll have x squared minus 6x plus 9. That would give me the perfect square trinomial, but then I have that minus 8 on the right. I will erase this side work. It's beginning to get crowded here. And now, going back to the equation, before I begin to exchange the perfect square trinomial into a binomial squared and begin to simplify things, I'm going to take the time to expose a pattern. This 9, I'm going to subtract it to both sides of the equation. And in doing so, on the left-hand side, I'll have 0. And on the right-hand side, I'll have the perfect square trinomial, minus 8. But now, I'm also going to have a minus 9. This is the pattern I want you to notice. Adding the same quantity to both sides of the equation is the same thing as adding and subtracting that same quantity on one side of the equation. We will apply this strategy when we wish to convert to vertex form. If we have a function, a quadratic function in standard form, and we want to convert it into vertex form, it will be very useful to apply this idea. So let me show you what I mean with this equation now. Here we have the same equation, but instead of it being equal to 0, we have it being equal to y. But the process is the same. To complete the square using these two terms, recall that we had to add a 9. So here we write this as y equals x squared minus 6x plus 9. That's the perfect square trinomial. And now we have to subtract the 8. Instead of adding 9 to the left-hand side, I'm going to subtract it right here on the right, which is exactly this idea that I exposed a few moments ago. Next, I will begin to simplify this. The perfect square trinomial, I can exchange it for a binomial squared. And negative 8 minus 9, we can combine them to make a negative 17. To find what goes inside of these parentheses, we grab x, and then we add half of the coefficient of x. So half of negative 6 is negative 3. And here you have the vertex form of the equation, of the original equation.